Thank you. Good afternoon, everyone. Current scientific theories of the atom are hypothesizing that the nucleus is made up of a chaotic blob of protons and neutrons. There is no known structure for the nucleus. Quantum mechanics states that it is impossible to show a true shape for the nucleus, but instead relies on mathematics to express the atom and its non-deterministic nature. Is it possible that there is a structure to the nucleus of the atom? In this presentation, I will make precisely that attempt and show you how this structure, with its particular rules and mechanics, are responsible for the periodicity and the groupings of the periodic table of the elements. My goal today is to take you from this two-dimensional solar system model of the atom with no structuring whatsoever, as we can see on this side. And I want to take you to a logical three-dimensional structure of the atom. The Proton-Electron model that was adhered to until the acceptance of the neutrons in about 1933 has been taken as a base for that. Now, before I continue, I would like to draw everybody's attention to the disclaimer of this presentation. We are all agreed that your theory is crazy. The question which divides us is whether it's crazy enough to have a chance of being correct. Niels Bohr. The presentation is made up of the following: the current understanding of the model, so we'll take you through a short history lesson there. And then we will go into the true proposal for the structured atom model. And the third part will be to touch upon some implications of this model. In the end, we will conclude. Our journey begins in the early 1800s when John Dalton was doing his research. Dalton used the relative atomic weight and published a table of the relative atomic weight, so we have the first rudimentary form of a periodic table of the elements. For example, Dalton found that 12 grams of carbon could react with 16 grams of oxygen to form the compound we now call carbon monoxide, or with 32 grams of oxygen to form carbon dioxide. The ratio of oxygen masses 32 to 16, which simplifies 2 to 1. At some point, it was discovered that certain elements have common properties and that there was a periodicity to the elements. In 1864, John Newlands described a law of octaves. He observed periodicity according to the relative atomic weight, identified some new elements such as germanium. His concept, however, was not recognized by the Society of Chemists until 1887. After becoming a teacher in 1867, Mendeleev wrote a definitive textbook of his time, Principles of Chemistry, 2 volumes in 1868 to 1870. It was written as he was preparing a textbook for his course. This is when he made his most important discovery. As he attempted to classify the elements according to their chemical properties, he noticed patterns that led him to postulate his periodic table. Mendeleev claimed to have envisioned the complete arrangement of the elements in a dream. Quote, "I saw in a dream a table where all the elements fell into place as required. Awakening, I immediately wrote it down on a piece of paper. Only in one place did a correction later seem necessary." So I would like to point out here, which is his periodic table, the purple elements like helium, neon, argon, krypton, etc., they were totally unknown. And here we see, for example, the germanium. By looking at these empty spots, we were able to pinpoint where the next element should be, and that's how we found them. The J.J. Thomson performed his Scaffold Ray Experiment in 1897. If a gas sample is introduced into the region between 2 charged plates, which we can see on the bottom here, a current flow can be observed, suggesting that the atoms have been broken down into charged constituents. The source of these charged particles is a heated cathode, in fact, causes the atoms of the sample to ionize. These were known as cathode rays at that time. In 1897, Thomson set out to prove that the cathode rays produced from the cathode were a stream of negatively charged particles called electrons. From Maxwell's theory, he knew that the charged particles could be deflected in a magnetic field, which is shown just about here. So, depending on the polarity, the electrons went up or down. Because of the bending of that path of the emitted electron in the cathode tube experiment, it became clear that it had to be a charged particle. Negative in nature because it was pushed from the north-south magnetic field that has been put into the electron beam path. Through his work, science was introduced to a whole new discovery, namely the electron. Through his work, the result was a model for the atom that acknowledged electrons and the fact that they can be taken away from the atom, leaving a positively charged atom. The discovery of these subatomic corpuscles overturned the notion that atoms are indivisible. The best description at that time was that it would resemble a plum pudding, whereby the electron resembled the distributed plum throughout the pudding, which is depicted here. He was, in the end, honored with the Nobel Prize in Physics in 1906. When Chadwick famously discovered the neutron, it caused a debate that was finally more or less settled at the 7th Solvay Conference in Brussels, Belgium in 1933. The only alternative to neutrons was the existence of nuclear electrons, which would counteract some of the proton charges of the nucleus. Since by then it was known that the nuclei had about twice the mass that could be accounted for if they were simply assembled from hydrogen nuclei, meaning protons. But how these nuclear electrons could be trapped in the nucleus was still a mystery. This is when and where it was decided at the Solvay conference that the neutron is not a combination of a proton and an electron, but rather a fundamental particle without an electrostatic charge, meaning it is neutral, hence the name neutron. After the acceptance of the neutron, which was very much influenced by the need to make quantum mechanics work, we basically end up with our current understanding, in essence at least, of the atom. I quote, "An atom has several key attributes that are observed. A positively charged nucleus. The nucleus is depicted here. The nucleus is made up of positive protons and neutral neutrons, the red and the green, if you will. Red, green. The electrons do, however, not fall into the nucleus. It's still a little bit of a mystery. And the ratio of the neutrons, protons, and the outer electrons on average is 1 on 1 on 1. Note that the current nuclear physics explains the nucleus in a quantum mechanical terms. In a nucleus occupying a certain energetic state, each nucleon is said to occupy a range of locations. To refresh everybody's mind here is what the current periodic table of the elements looks like. We see there is a periodicity and groupings in the list of elements. The periodicity goes from the left to the right, and the groupings come from top to bottom. The term element is used for atoms with a given number of protons, regardless of whether or not they are ionized or chemically bonded, for example, hydrogen in water. In short, the number of protons and the outer electrons determines the element. When all this is taken into account, the current understanding of the atoms and the elements is very poor, to say the least. If this is all that is offered after a century of research and untold amounts of resources, having been poured into technological projects based on this, then I would feel disappointed in fact. This is what drove me to study the atom and the elements. The disappointment of, in truth, a highly disputable model that asks us to believe certain things, in order to make it work, could simply not satisfy my need to know. Throughout the years, my personal lesson was that the whole basics was wrong. This started for me at around 2006, and ever since the model has been slowly growing and maturing. The strong force, which is seen at the first bullet point, is a postulated force. It simply was needed in order to explain how the protons would stick together in the nucleus. So, any good model should be based on observations and logic. Only after that comes the understanding of the whole, or the narrative, if you will. The structured atom model has the following key features. It shows a logical construction of the atom in accordance with observations. It explains why the atom has a positive nucleus with negative electrons around it. It explains why the electrons do not fall into the positive nucleus. It explains in a logical manner how chemistry arises. It explains the periodicity of the periodic table of the elements. And still an open question, why do electrons and protons not annihilate each other? Still unanswered. SAM is a new model. No, yes, take your pick. Let's see. This model is still very much in development, and despite some efforts to the question as to why the proton and the electron do not annihilate each other is still unanswered. The only thing I would like to add is that the observation would indicate that perhaps the proton and the electron are made up of smaller organizations. The model right now does not rule this out nor deny it. In fact, I think this is a beautiful example of how we can cooperate from different disciplines to find the answer to this question. For the model itself, it is not essential to have this question answered because it goes beyond the scope of the organization of the nucleus. The observation is still there, regardless of the answer to the question. There has to be an organization to the nucleus of the atom. There's simply too many hints and leads that cannot be ignored that point to this to be true. When we try to find an answer to how the nucleus of the atom is organized, we can find no real answers at all. Only that the nucleus is made up of neutrons and protons. How these fit together is officially still a mystery. This presentation will offer evidence that the nucleus is structured, and will point out how this is the case with its regularities and rules, and what principles are in effect. At about 2008, I found a correlation of the geometry of the spheres. It's called Spherical Geometry. You'll be surprised how little can be found on that. When we reach the number 7, we reach lithium. It's called a pentagonal bipyramid with a fancy word. And in 2010, I understood that the carbon corresponded with the icosahedron, or rather 12 spheres. In 2012, I found basically an entire structure of the nucleus and how it functions. Ever since, I have been a student myself of this model. And I can find correlation after correlation. Some of these I hope to share with you here. And the model, in short, comes down to this. We have a duality, which is depicted here on this slide, that we call a proton-electron pair that has the electrostatic force acting between them, and this force is the causal factor for the principle of the densest packing that creates geometric shapes. These geometric shapes are integrated in a specific order and number, and they create all the elements. During the next slides, I will try to show you how that is the case. So when we go into the structure of the atom model, I would like to point out these postulations/observations that the model is based upon. There's only one fundamental force, the electrostatic force. The atom must have a definitive organization which is responsible for all the attributes of a particular element. The neutron is not a fundamental particle. It's a composite of a proton-electron, but it's redefined as a connection between a nuclear electron and its surrounding protons. A stable element must have a stable nucleus, i.e. there can be no movement without any cause in the structure of the nucleus. A sphere, or a proton, must always be part of one of the three identified geometrical structures, namely the tetrahedron, the pentagonal bipyramid, or the icosahedron. The depictions will come in a little bit. And the inner structure of the atom, the nucleus, dictates the outer electron structures, or rather the orbitals. So, when we reach the new neutron, this is a schematic view of it. In the center, we can see how the neutron is redefined. Instead of being a fundamental particle, it is, in the center, an electron with its two neighboring protons. This is a stable structure. The charge of the electron in the center is divided over the protons. This binds the protons into a rigid connection, if you will. It resembles the nucleus in a stable configuration. The second electron, to make the whole neutral again, is simply booted out. It's placed in orbit, which is about 100,000 times the radius of the nucleus. On the left, we can see schematically how the free neutron decay occurs. So at the bottom, we can see an intimately connected proton and electron, meaning there is no more energy in that system. It does decay, however, into the top depiction of basically a hydrogen atom, a proton and electron at a distance. On the bottom right, we can see what happens when we go into a triangular configuration which is depicted by helium-3. There's simply no room for more than one nuclear electron. They're too close to each other. The other two, which are depicted in the green here, are simply booted out again. But to balance the whole being free protons and free electrons. Above that, we see how we end up with a helium-3 with only one nuclear electron, taking its resting position in the center of the three protons, or at least it is seeking out that point. So in classical terms, we are left with only one neutron, two protons, and two outer electrons. I would like to point out a paper done by Carl Johnson, actually more than one paper, and it's called The Statistical Analysis of Isotope Masses. This analysis of the precise NIST data seems to indicate that there is no energy which exists within any atomic nuclei to account for the existence of any pi mesons or the necessary binding energy of any neutrons, or of any ultra-powerful strong force, or any neutrinos for that matter. The research has resulted in a far yes? In a far simpler and more logical description of atomic nuclei. It also entirely complies with the known laws of science. No unseen strong nuclear force, which allegedly works at an infer fifth power distance, except then it also reverses, in effect, at really short dimensions, is either necessary or represented by any energy source. I would like to invite everybody that is very interested in this topic to try and seek out those papers. Quite profound. Here we see the building blocks of the model. From left to right, we can identify them. Here we see the Platonic solids, the Platonic solids. This is on the bottom we see the spherical geometry. The spherical geometry is not like the so-called Hody geometry, which uses points and lines in a two-dimensional depiction. Here we can see how the Platonic Platonic shapes are actually created by using spheres, in this case the protons. And as Plato already said, the atoms must be made up of geometrical shapes. This picture here was taken last year at the Curb, sitting at the Grand Canyon. And I would like to point out this gentleman with the red hat, James Sorensen. Ever since we met, James has been participating in this model. By creating software code that led to a three-dimensional atom builder, we can actually recreate on the computer the elements. The picture you see here the pictures you will see during this presentation are taken from that particular atom builder. The model has already been proven to be crucial for further continuation. On the left, we see the basic building blocks. The first one would be hydrogen, the second one would be deuterium, the third one would be helium-3, fourth, helium. This one is the so-called pentagonal bipyramid, which equates to lithium, the first true element that we have in the periodic table. Even the name implies this, because it's lithium meaning stone, stone-like. And the last one represents carbon. Here we see, give me a second. Here we see some essential tools in the college that we used to develop the model. Nothing fancy, nothing expensive. The magnets that we can see on the bottom here are used as a valuable tool because they mimic the central attraction force that is also available, also there in the atomic nucleus. This beautiful mimicry the densest packing, or rather the electrostatic force. Treated properly, they will show you the correct structure of the elements. Everybody can do this. Here we see the Platonic solids again, created using spheres, the so-called spherical geometry. Take note that the cube and the dodecahedron are not stable. They can easily be distorted, in contrast to the other three. So the cube is not stable. The tetrahedron is stable. The icosahedron is stable. The dodecahedron is not stable. And the octahedron is stable. The proton geometrical structure cannot exist on its own, nor can an electron structure be on its own. They need each other. They need each other in order to be in equilibrium. Only one on its own cannot be, the other one on its own cannot be. Together they can be, they are in equilibrium. All the protons that we have in this model must belong to three geometrical structures. As I said, the tetrahedron here, the pentagonal bipyramid represented by lithium, and the icosahedron represented by carbon. On the left, we have the electron structures, which is an octahedron and a dodecahedron. On the bottom here, I try to show how they exactly fit together. Oh, let me see. Let me check that. The icosahedron is the most complete of the Platonic solids, meaning there is no bigger geometrical shape that can fit into a sphere, i.e. there is no bigger geometrical structure. The combination of protons and electrons pulled towards its shared common center of that icosahedron. This is the primary argument for the applicability of the densest packing principle. Carbon embodies the icosahedron with its 20 triangular facets. Let me see if this is right. Right. Carbon embodies this icosahedron with its 20 triangular facets. The 20 triangles correspond to the number of electrons necessary to reach the noble gaseous state. With carbon, as is depicted here, not all the triangular facets of the nucleus are occupied, meaning there are positive spots left on the nucleus that can still react. In the green, we can see where an electron would be, and where there is no green yet, like here or here, is still the positive charge left. So on the left, we see a carbon with only 6 inner electrons. On the right, we have a carbon with the 6 inner electrons and the 6 outer electrons. However, take note, not all the spots are still green, meaning there's still chemical reactivity left. This is basically the fundamental principle as to why chemistry is happening. When we take a look at the noble gas configuration, we have the same nucleus. However, there are, like shown on the right, extra protons. These extra protons also imply there are extra electrons. And in the case of neon, we get the first complete nucleus, if you will, whereby all the spots are occupied. Hence, we reach the noble gaseous state. It's important to notice that this icosahedron of the carbon, which is still depicted here, has 20 triangular surfaces. So we get 10 inner electrons, 10 outer electrons. Together they will occupy no more positive charge, no more negative charge, no more reactivity. Hence, again, the noble gaseous state. The main structure of the atom, or the backbone of the nucleus, is made up of the icosahedron, or as determined in this model, a carbon nuclet, whereby nuclet refers to the identified geometrical shapes of the protons. Each geometrical shape or nuclet has a center of attraction that is created and shared by the protons that are part of that nuclet. The geometrical structures are connected to each other by sharing a proton, as shown on the first image here. The main structure of the atom is therefore a collection of the connected carbon nuclets that adhere to a doubling mechanism. And we tried to depict it in the rest of the pictures here. We go from 1 carbon nuclet to 2 carbon nuclets to 4 carbon nuclets to 8 carbon nuclets. This triangle, as you can see, it's everywhere on the nucleus of the atom. This is most important. All the proton structures will always have only triangular surface areas. This is when it is stable. So this triangular area is where an electron would find its resting spot, or at least balance out and try to find that position. Here we see how the periodicity of the periodic table is a result of these geometrical shapes. Oh, give me a second there. Excuse me. What we see here is highlighted the carbon group in the periodic table. The carbon group belongs, carbon belongs there, silicon belongs there, germanium belongs there. When we go to the shapes, we get this picture. On the left we see carbon made up of 12 nucleons or protons. In the center, we see silicon, which is 28 in total. However, on the left, we see the same recurring carbon nuclet, which is where all the reactivity or the chemistry is. On the right, we see the green. Every time we see green, it resembles a neutralized spot, meaning that part of the atom or the nucleus does not participate anymore. When we reach germanium, which is made up of 70 nucleons or protons, we can see that basically the whole atom is neutralized. And again, the same recurring carbon nuclet. The numbers still add up. So when we see in this model these numbers here, they correspond exactly to the element. Another example is the Akali metal group, so lithium, sodium, and potassium. And when we try and take a look at those shapes, we get the following picture. On the left, we see lithium with 7 particles in the pentagonal bipyramid. On the center, we get sodium, 23 particles. Again, the only active part of the atom is the red part here. And to the left, again, the neutralized part. On the right, potassium, 39. The whole atom is neutralized except for that lithium nuclide. A final example would be the noble gases. So we've taken neon, argon, krypton. When we take a look at their shapes, we get the following picture. Everything is completely greened. Only neutral endings, as I call them. And we see neon with 22 in this case. Neon has 20, 21, 22 as a stable isotope. Chosen 22 here. Argon with 38 here. And krypton with 80 here. And this keeps on recurring. This keeps repeating. The cycle of 8. Here we see how the periodicity of the periodic table of the elements is a result of these geometrical shapes. So the valence factor, or rather how many connections we can make with a certain element, we can see that the carbon is usually taught to us as being a +4 or a -4. The nitrogen being a -3, the oxygen -2, the fluorine -1. We can see the number of green increasing, meaning every time a pair is added, that part of the atom is neutralized, and the valence factor is dropping by 1. When we continue, we reach neon, completely neutral. Sodium, however, is +1, represented by the lithium nuclide again, as we saw in the previous example. Magnesium simply has 2 of those. Aluminum, a little bit more complex, it has a lithium nuclide, or geometrical shape. And on the right side, we see the yellow, which is representing a beryllium nuclide, just a little bit heavier than the lithium. After that comes silicon. Silicon, again, is +4, -4, and +2. But we see, just as above, the carbon nuclide, and here the active carbon nuclide. On the right side, the atom again is neutralized. This keeps repeating and repeating and repeating. The periodicity of the periodic table of the elements. Let's see where we are. Right. Carbon-14, most commonly known example, I would say. Carbon-14 is radioactive and decays in approximately 5,000 years or something to that effect. And we see the densest packing at work. We can see here in the center is a general depiction found on Wikipedia, for example, how an electron is booted out. Or, in this case, over here, we see how a neutron decays into a proton and an electron. They also talk about neutrinos, antineutrinos, but we leave them out for a moment. On the right side, we can see here, according to the new model, we can see carbon-14. In the center, we have that same carbon nuclide that was blue just a moment ago. And we have on the top 1 extra neutron, and on the bottom 1 extra neutron. Meaning it's a proton plus an electron to bind them together. When they come close, they decay. Meaning the 2 are together now, and there's only 1 electron needed, or rather, actually, there's only room for 1 electron. So the second electron is booted out, as we could see here. It takes its place in the orbit, and therefore we reach the next element. So you could say in classical terms that the numbers are 6 protons, 6 electrons, and 8 neutrons, becoming 7 protons, 7 electrons, and 7 neutrons. That's the decay. If we talk in the new model, we actually have, so over here, 14 protons with 8 inner electrons, the 6 of the carbon plus the 2 of the loose neutrons, and the 6 outer electrons that have always been there. And it decays to the bottom simply to, again, 14 protons, 7 inner electrons, and 7 outer electrons. This is the so-called beta-minus decay. Now, Our current research still focuses very much on these structures. And we're trying to create a corresponding periodic table of the elements. Not so much that the current one is wrong, but there are some improvements to be made. Half the elements have to still have to be created in the atom builder that was mentioned before. We're not there yet. It's quite complex because of the number of possibilities that arise due to the doubling factor. Let's see, nature. So we are currently, for example, looking at the possibility of the existence of elements halfway the periodic table of the elements that have not yet been discovered. I'm not talking about the real heavy elements. I'm talking about elements halfway the periodic table, close to iron, close to copper, close to silver, gold, etc. Nature tends to skip these steps, not so much because it cannot be done, but because the combination of two to make the fusion happen, usually we get a helium nuclei or a alpha particle which combines. An alpha particle consists of 4 of these protons. But to create that missing element in between, we need a deuterium to act on that. Just chance-based, and the abundancy of certain elements makes it almost impossible. Besides that, we are not even aware that there might be something missing. It is my belief that ultimately these elements will be either discovered or created, and I hope and think might actually validate this model in the future. We can see here how it basically resembles a tree-like structure and where this doubling factor is coming on. So this is like a stem, 2 branches, which goes into another 2 branches and another 2 branches, or rather 4. Interesting to note, over here there's a collision. The 2 branches basically touch each other, and that happens just about where the stable elements, lead and bismuth, are the most stable last elements in the periodic table. From that point on, all the elements are radioactive. I believe that due to that coming together of the branches is where it breaks. And the bottom basically breaks up and the atom is split in 2. I think we all know what that leads to. This theory is still far from complete. It provides actually opportunities for everybody to participate in this advancement. There are limitations to specific fields of science due to limited understanding of the atom, I believe, in general and the elements specifically. The atoms affect just about everything. In fact, I would like to challenge the scientific community to either point out these flaws and provide the next answer, or a clue, or an error, or validate a proposed model. This is something I think we should all agree on. All that is presented here today can only be done, has been done without any professional support, and represents a few creative minds working together. And I can only imagine what we could achieve as a collective. We see here a screenshot basically of the atom builder that has been created. Again, James Sorensen has been most important in this. He has been able to convey the model that I had in its rudimentary form into this atom builder, and we can see here some of that. Anybody that is interested in this and learning more about this, I would like to invite to the breakout room where I have a beautiful setup, and we have lots of examples. We have magnets you can use and create and play with. I would like to summarize the new atomic model as followed. We have a duality that we call a proton-electron pair with the electrostatic force acting between them. This force is the causal mechanism for the principle of densest packing that creates geometrical shapes. These geometrical shapes in a specific ordered sequence and number create all the elements. The model shows the observed nature and properties of the atom and explains the reason why the nucleus of the atom is positively charged, why the outer electrons stay at range and do not fall into the nucleus, and addresses a causal factor for chemistry. In fact, physics and chemistry are kind of separated exactly where the atom is. In this case, the physical model goes straight into the chemistry. And there are many, many more implications and consequences, too many to mention today. There's some potential implications here, and I named some here. We have plasma physics, astrophysics, cosmology. I think we can reach a far better understanding of the nuclear structure. Better understanding of chemistry, nuclear fusion and fission. Maybe even smaller nanotechnology, radiometric dating, which is to say the least is quite controversial, transmutations, and perhaps, as I mentioned, new elements. To conclude with the thanks, many people to thanks, but a few persons in particular, Susie Schrott, Mark Span, Jean Hafner, for your EU support. Unwavering, I would say. James Sorensen, special. He made the Atom Builder and a website, and that will become, in the end, I hope, a tool that we can use for educational purposes. Jan Emming for the text editing and his unwavering support as well. Karen Elkins with graphical representations and feedback. And I would like to conclude there. Unfortunately, I cannot show you an animation, but again, I would like to invite you to the breakout room where we have some lovely animations going. And I would like to thank you for your attention.